Lab 3 IPv4 Subnetting with VLSM. So in Lab 4 we have two problems. Okay, problem 1, problem 2. So both the problems is going to be based on the VLSM concept, variable length subnet mask. So both the problems I'm going to solve it here. Okay, now so this is the topology diagram given to us. For this topology diagram we have to assign the IP address by using the VLSM concept. Now if you see this topology diagram, the number of networks, so this is 1. Okay, so the first network, and this is the second network, this is the third network, and this is the fourth network. So totally there are 4 different networks available in this topology diagram. Now in each network how many hosts available? Okay, we have to find it. Now 1, 2, 3, 4. So there are 4 hosts available here, and here it is 1, 2, 3, 4. So we need 4 IP address here, and here we need 2 IP address. Then here 1, 2, 3, 4. So we need 4 IP address for this network. So 3 networks, it is having the equal number of hosts. So 4, 4, 4, and then this one is having 2. Okay. Now, so you have to write it in the ascending order. Okay. For example, this is subnet A, this is subnet B, this is subnet C, and this is subnet D. So I'm writing here A, B, C, D. So we need 4 subnets. For the first subnet you are having 4 hosts, for the second subnet 4 hosts, and here it is 4, and the last one it is going to be 2. So in this way you have to assign the IP address. So what is a major network? So the major network given here is 220.255.255.0/24 actually. Okay, because this is class C. Okay, so this is the major network given. So now we have to assign the IP address, so based on the VLSM concept. Okay, so let me solve this problem. Now we are going for the problem. So 4 subnets A, B, C, D. So the number of hosts in the subnet A 4, the number of hosts in subnet B 4, in subnet C also we have 4 hosts, and in the subnet D we are having 2 hosts. Okay. Now, so the major network given to us, it is 220.25.25.0. So this is class C, so it is going to be 24. So we no need to write the default subnet mask, everything. We can go to the problem. Okay. Now I'm going for the subnet 1. Subnet 1. So the number of hosts needed. Okay. How many hosts means? So number of hosts equal to 4. Now if you need 4 hosts, okay, we are going in the reverse approach. If you compare with the subnetting and this, so this will be slightly in the reverse approach you have to go. Okay, now number of host 4. If you need the number of host, okay, 4 host if you need, how many bits should be available in the host part? Okay, we have to calculate like this. I repeat, see, 220 is the first octet, then 25 second octet, there is no change. The third octet is also going to be 25. So in the fourth octet we have 8 bits. We are not going to borrow, we are going to do it in the reverse. Okay, we are going to borrow, but how? Okay, we will see. So 1, 2, 3, 4, 5, 6, 7. There are 7 bits available. Now I need 4 hosts. Okay, I need 4 hosts. So if you need 4 hosts, how many bits you need in the host part? Okay, we are going to decide this. The remaining bits we are going to move it to the network. What we have done in the previous examples, okay, in the subnetting, we are going to decide the number of, okay, subnets, and we are dividing here. But here it is slightly a reverse one. Okay, let me solve it. Now 2 to the power of 1 minus 2. Okay, this is the formula I am going to apply. Then 2 to the power of 2 minus 2, 2 to the power of 3 minus 2. Okay, so this is enough because only 4 we need. So this is 2 to the power of 1. It is going to be 2 to the power of 1. This is going to be 0. This one 4 minus 2. So this is going to be 8 minus 2. Now, so this is 4 minus 2, it is 2. Okay, only 2 host, and here it is going to be 6. Okay, now, so what we are understanding, if you have 3 bits, okay, if you have 3 bits in the host part, you can connect 6 hosts, you can connect. If you have 2 bits in the host part, you can connect 2 IP address, that means 2 valid IP address you can have. But here I need 4 IP address I need. So if you need 4 IP addresses, what you have to do, you must have 3 bits in the host part. So 1, 2, 3. So 3 bits I'm going to fix it here. Okay, this is going to be the host. Okay, for me this is the host. The remaining thing I'm going to move it for the subnet. Okay, so the same thing we have done in the reverse approach in the previous problems. In the subnetting, we will decide the number of subnet bits, then remaining we will leave it for the host. But here it is not like that. You have to fix it for the host first, then the remaining you are going to move it for the subnet. So 6 host if you want to connect. Actually I need 4, but 4 exactly we cannot bring. So 6 host if you connect. If you want to connect 6 host means, so 3 bits should be available, okay, in the host part. Then naturally there will be a question, why this minus 2? Okay, why we have to minus, okay, this 2. So this 2 why we are going to reduce means, one IP address we are going for the subnet ID, and the one more IP address we are going to give it for the broadcast IP address. So if you see the topology diagram, so in this topology diagram we have 4 valid IP address, 1, 2, 3, 4 IP address you need, plus another 2 IP address you need. What is that? One is for the network ID. For this network we have to give one ID, that is a network ID. Then for the broadcast IP address for this network, so 2 we have to reduce from that. So that is the meaning here. So I reduced 2. Now, so we decided 3 bits are enough. Okay, if you have 3 bits in the host part, it is enough. Okay, you can connect 6 computers, you can connect. Okay, now I'm going for the subnet ID now. Okay, before that we have to go for the custom subnet mask. Custom subnet mask. Okay, we have to find the subnet mask. Okay, so subnet mask, the first part is going to be 255 because it is class C. Second part also 255. Third part also it is going to be 255. Then in the fourth octet we are going to have only 3 bits. Okay, we are going to have only 3 bits in the host. The remaining 5 bits you are going to move. So 1, 2, 3, 4, 5. The remaining 5 bits you are moving here, okay, to the network part. So if you find the equivalent binary value, that means you can apply the place value 1, 2, 4, 8, 16, 32, 64, 128. Okay, you can add everything. Okay, this is going to be 1, 2, 4. So I can go for the reverse approach. So total is 255. 255 minus 4 plus 1, 5, 5 plus 2, okay, 7. So 7 if you reduce from this, it is enough. Okay, so 15. Okay, so this is going to be 8, and here it is going to be 4, and this is 248. Okay, so 248. So the custom subnet mask is 255, 255, 255.248. Okay, so what is the CIDR value? So the custom CIDR value 8 bits, 8 bits, 8 bits, and then here it is going to be 5 bits, 1, 2, 3, 4, 5. So 24, 25, 26, 27, 28, 29. So this is going to be /29. Now I'm going for the subnet ID. So for the first subnet we are going for the subnet ID. Okay, we are now dealing with subnet A. Okay, for the first subnet we are dealing. Now subnet ID. So what is the subnet ID means? Okay, let me write 220.25.25. Okay, so 8 bits available, 1, 2, 3, 4, 5 bits we borrowed, 3 bits is going to be in the host. Okay, so what the subnet, how to find the subnet ID means, you have to make everything 0. Okay, so this is the first subnet, so I make this 0. Make all zeros in the host part. So this is going to be your host. In the host part you have to make everything 0. So this is going to be same 220. Okay, 25, 25.0. So this is going to be your subnet ID /29. Then first host ID. So what is the first host ID means? You can see 220.25.25. So here 1, 2, 3, 4, 5. First 5 bits it is going to be 0 because this is your subnet. Okay, you cannot change that. The remaining 3 bits is available. So the first host is, the last bit should be 1. Now, so this is going to be 220.25.25.1/29. So this is your first host ID. Then last host ID. Okay, so 25.25. So in the last octet 1, 2, 3, 4, 5 bits available. So this should be 0. You cannot change this because this is the network ID, subnet ID. So there are 3 bits available here. So what is the formula? You have to make everything 1 except the last bit 0. Okay, in the host. So this is going to be your host part. Now I'm going to convert this into equivalent decimal. So 220.25.25. So this is 124. Okay, so 4 plus 2, 6. So this is going to be 6/29. Then broadcast IP address. So broadcast IP address, naturally you can add 1 with this, no need to do any calculations. So this is going to be 7. So 220.25.25.7/29. Okay, so this is going to be your broadcast IP address. Now you see, if you have 3 bits, okay, if you have 3 bits, you can have 6 computers you can connect. This is what we decided here. Okay, if you have 3 bits in the host part, you can connect 6 computers. Okay, now you see first host ID. What is the first host ID? It is 25.1. This is the first host. What is the last host ID? Means 6. So 25.1, 25.2.3.4.5.6. So this is going to be your first host. This is going to be your last host. Then we have reduced to -2 we have done. So this -2 I already told what is that, subnet ID and broadcast IP address. Now you can see this is your subnet ID. So I reduced that, and this is going to be your broadcast IP address. So what we have done means we took only 8 IP address we took from that, okay, the major network. So this is going to be your network ID, subnet ID. So this is going to be your first host ID, and this is your last host ID, and then this is going to be your broadcast IP address. So the broadcast IP address is this. So this is how we have to do the VLSM. So this is I have done only for the first subnet A. Now I'm going for the second subnet. Okay, I'm going to do the same thing for the second subnet. So that means B. Okay, so we are going for subnet B. So I'm taking B. So here also, how many subnets you need? Means you need 4 subnets you need. Okay, so number of host. So number of host, okay, equal to 4. So the same thing. If you need 4 host means the formula is going to be same. So 2 to the power of n minus 2. Okay, so this is equal to, so 2 to the power of 3. Okay, 3 minus 2. So this is equal to, so 2 to the power of 3 is 8. So 8 minus 2 is equal to 6. So the same number of bits you are going to have. Okay, now I'm going for the subnet ID. I'm going to find the subnet ID. So here the CIDR value is /24. 3 bits you are going to borrow. So 25, 26, 27, sorry, 24, 25, 26, 27. Sorry. I'm sorry. 3 bits it is going to be in the host. So 5 bits you are going to borrow. Okay. So 3 bits is going to be, okay, in the host. So 5 bits you are going to borrow. Okay. So in that case, so 24 plus 5. Okay. That is equal to 29. Okay. 29. So 20/29 is going to be CIDR. So because same for A and B, number of hosts is same. So you are going to have the same CIDR value you are going to have. Now I'm going for the subnet ID. Okay, now what we have to do here, see here. In the previous subnet, in the broadcast IP address, we have 220 25, 25, 7. You have to take the next IP address, you have to take it here. Okay, so what will be the next IP address means, the next IP address is, okay, I'm writing here, it is 220, 25, 25. We stopped there at 7. So now I'm going to take this as 8. So I'm going to take 8 as the beginning. That means the first starting we are going to take 8. Now let me convert this, okay, in the octet format. So first it is 220. We are not going to do any change there. Second part it is 25. No change. Third octet is also there is no change. But if you go for the fourth octet, so we need 3 bits for the host. So 1, 2, 3. 3 bits for the host is enough. The remaining 5 bits, 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5. So 5 bits is going to be in the network part. Now, already we have a 8 here. So this 8 we have to maintain. So what is that? 1, 2, 4, 8. So this 8 we are going to maintain here. Okay, now you see 0, 0, 0, 0, 1. This is our first subnet. Okay, actually 0, 0, 0 is the first subnet. This is our second subnet actually. Okay, this is going to be. Now, what is the subnet ID? So subnet ID is the host part. You have to make everything 0. So 220, 25, 25. Okay. The last part, okay, everything is going to be 0, but here 8 is available. Okay, we have to maintain. So this is 8. So /29. This is going to be your subnet ID. Then next one is first host ID. So the first host ID is 220, 25, 25. Okay, so here the same 8 bits available. 1, 2, 3, 4, 5, 6, 7, 8 bits. So we are having 3 bits in the host part. So here it is going to be 1. Now, what is the first host ID means? All the bits in the host should be 0 except the last bit. So this is the host part. So here it should be 1. So if you convert this, so 220, 25, 25. So this is going to be the place value. You can take the place value 1, 2, 4, 8. So 8 plus 1. So this is going to be 9. Okay, /29. So this is the first host ID. Now I'm going for the last host ID. So the formula here is you have to make everything 1 except the last bit 0. So in that case 220, 25, 25. So here 8 is there. I just keep 8. You have to make everything 1 except the last bit. So 4 plus 2. Okay, 4 plus 2. So this is equal to 220, 25, 25. So 8 plus 2, 10, 10 plus 4, 14. So 14/29. Now, then broadcast IP address. So naturally, broadcast IP address is going to be +1. So 220, 25, 25, 15. Okay, /29. This is going to be the broadcast IP address. Now, we will check it. See here. First host is 9. Okay, so the last host is 14. So you can see 9, 10, 11, 12, 13, 14. So how many hosts you can connect means, so 1, 2, 3, 4, 5, 6. Okay, 6 hosts we can connect. So exactly the calculation is correct. So now you can see, so 2 to the power of 3 minus 2 equal to 6. Okay, so 2 to the power of minus 2 equal to 6. So that means if you have 3 bits in the host, you can connect 6 hosts. So this is the 6 host you can connect. 6 IP address we got. 220.25.25.9, 10, 11, 12, 13, 14. So this is going to be your broadcast. So this is our subnet ID. This is our first host ID. So this is the last host ID. And this is going to be your broadcast IP address. Now, I'm going for the next subnet. The next subnet is B. Okay, sorry, C. Okay, so here also the number of hosts you need, it is 4. Okay, so number of host. Okay, so number of host is equal to 4. The same thing, so 2 to the power of 3. So you need 3 bits here. 2 to the power of 3 minus 2 equal to 6. Okay, so 3 bits should be available in the host. The same thing, it is not going to change, but for the fourth subnet it will change. Okay, we are going to see that now. Subnet ID, directly I am going for the subnet ID. So we finished here in 15, so we have to take next one as a 16. So 220.25.25.16. So now you can write it directly. Okay, so this is going to be /29. This is your subnet ID. Now first host ID. So what is the first host ID means? So this plus 1. So 220 plus 25.25.17. So this is going to be your first host ID. Then last host ID. So what is the last host ID means? 220.25.25. So last host ID I am going to calculate. So 1, 2, 3, 4, 5 bits. Okay, 3 bits in the host. So here in the subnet ID we have 16. So 1, 2, 4, 8, 16. Okay, so it should be 1. So this is your subnet ID. Now, so what is the last host ID means? For the last host ID, you have to make everything 1 except the last bit. Okay, except the last bit 0. So if you convert like this, so this is going to be 220, 25, 25. So you can apply the place value 1, 2, 4, 8, 16. So 16 plus 4 plus 2. Okay, 16 plus 4 plus 2. So 16 plus 4, 20, 22. So 220.25, 25. Okay, so 622. Okay, so this is going to be your last host IP. You can count it. Okay, so 17 is there. So 17, 18, 19, 20, 21, 22. So 1, 2, 3, 4, 5, 6. Okay, so 6 valid IP address available. Then broadcast IP address. So the broadcast IP address is 220, 25, 25. So plus 1. Okay, it is going to be 23. So 23/29. So this is your subnet ID. Okay, so this is your subnet ID. So this is your first host ID. The first host ID is 17. So the last host ID is 22. Then your broadcast IP address is this. So this is going to be your broadcast IP address. Now I'm going for the fourth subnet. So the fourth subnet is D. So here the number of hosts is only 2. Okay, so I'm going for the if you want you can see the topology diagram. So in the topology diagram we already decided. Okay, so the last subnet it is going to be D. The number of hosts, so how many hosts available means only 2. So if you need 2 IP addresses is enough. Okay, only 2 IP addresses we need. Okay, now so we are going for the last subnet now. Okay, subnet D. Okay, I'm going for subnet D. So here the number of host. Okay, number of host. Okay, so how many hosts I need means the number of hosts is equal to 2. Only 2 hosts I need. Okay, so now I'm going to apply the formula 2 to the power of n minus 2. Okay, so we'll go for 2 to the power of 2. 2 to the power of 2 power 2 means this 4 minus 2 is equal to 2. Okay, 2 to the power of 2 it is 4 minus 2 equal to 2. So that means if you have 2 bits in the host part, if you have 2 bits, okay, you can connect two hosts. You can connect. You will get 2 valid IP address. Okay, that is the meaning. Okay, so now 2 is enough. So in that case, we are going for the CIDR value. Okay, now subnet mask. Okay, custom CIDR. First, let me find CIDR. So what is the custom CIDR means? So this is class C. We are dealing with class C IP address. So by default, it is 24. Now I decided only 2 bits is enough. Okay, for the host. The remaining 6 bits I am going to move it for the network. So 24 plus 6. Okay, because 2 bits we are going to keep it for the host. The remaining we are going to push it to the subnet. So 24 plus 2. Okay, so this is going to be 30. So the CIDR value is equal to /30. Okay, now what is the custom? Okay, so custom subnet mask. Okay, so the custom subnet mask is now 255 first octet, second octet 255, third octet 255. So in the fourth octet, so what we have done, so we borrowed 6 bits we borrowed. So 2 bits only you are going to keep it now. So I'm going to borrow 6 bits here. 1, 2, 3, 4, 5, 6, 7. Totally 8 bits available. 1, 2, 3, 4, 5, 6. So 6 bits we are going to borrow here. So if you borrow 6 bits, okay, so this all it should be 1. Okay, now using the place value, you can convert this into decimal number. So 1, 2, 4, 8, 16, 32, 64, 128. Now you can convert this into decimal. So this is going to be 255 dot 255 dot 255 dot. So you have to add everything. So instead of add, okay, you can just reduce 3. Okay, so 255 minus 3. Okay, so 2 plus 1, just if you reduce 3 it is enough. So it is going to be 252. So now the subnet mask is 252. So this is the subnet mask. Okay, now I'm going for the subnet ID. Okay, so you have to go for the previous IP address where we stopped. Okay, because we have to continue with it. Okay, so then only it will be a correct one. So now if you see the previous subnet for class C, we stopped in, okay, the broadcast IP address is 220, 25, 25, 23. So the next IP address we have to start. So the next IP address is going to be 24. So 23, okay, it is over. 24 we have to start. So subnet ID is equal to 220.2525, okay, 24, okay, /30. This is variable length subnet mask. Now, so first host ID, I'm going for the first host ID. So 220.25.25, okay. So here we have 6 bits in the network. So 1, 2, 3, 4, 5, 6, 7. So total is 8 bits. So only 2 bits it is going to be in the host part. The remaining thing it is going to be in the network part. So in this case already we have a 24 here. So this 24 I am going to convert into binary using the place value. So this is 1, 2, 4, 8, 16, 32. So 64, 128. Okay, so now, so 24 if you convert into binary, so 16. Okay, so 16 plus 8. Okay, it is going to be 24. So only these 2 place values I am just make it 1. Remaining thing is going to be 0. Now, what is the first host ID means? The formula is we have to make the last bit 1. So if you make last bit 1, 24 plus 1, okay, we have to add. So first host ID is 220.25.25. Okay, so this is already 16 plus 8, 24. So 24 plus 1 it is going to be 25. So this is going to be your first host ID. Yeah, first host IP. Okay, so this is /30. Then the last host ID, okay, you can see 220.25.25. Okay, so already here, okay, 24 is available. 1, 2, 3, 4, 5, 6, 7, 8. No need to do like that. You can directly write it. But anyway, so 1, 2, 3, 4, 5, 6. Okay, so the 6 bits, 1, 2, 3, 4, 5, 6 bits. Okay, it is available in the network. So only 2 bits available in the host. Okay, so only 2 bits available in the host. Okay, now, so this is going to be 1. Sorry. So little confused. Wait, I repeat the last host again. Okay, I'm doing the last host again. So last host ID is 220.255.255. So here we have 8 bits. So 1, 2, 3, 4, 5, 6, 7. So this is 8 bits. So in the host part we are going to have only 2. Okay, 2 bits is available, remaining 6 bits available in the network. So this is going to be the host and this is going to be the subnet, and the whole thing is going to be your network. Now, so here if you see we have 16 and 8. Okay, that means this is 0, 1, 1. It is already there. Okay, now what is the formula to find the last host ID? Means you have to make everything 1, last bit 0. So that means this bit is going to be 1 and here it is going to be 0. So 1, 2, 4, 8, 16. Okay, so you have to add all these things, 16 plus 8 plus 2. So yeah, 2. So 8 plus 2. Okay, 10. 10 plus 6, 26. So this is going to be 220, 25, 25. It is going to be 26. Okay, 26 slash 30. Okay, that means CIDR value is 13. Okay, nothing, no need to confuse. So first host ID is 25, last host ID is 26. So how many valid hosts you need? Only 2 valid, okay, IP address you need. So this is going to be 25, 26. Then, so what is the broadcast IP address? So this plus 1. So 220, 25, 25, 27. So this is going to be your broadcast IP address. So for the last subnet, we need only 2 hosts we need. Okay, so we decided to have only 2 bits in the host part. So we took only 2 bits. So the subnet ID is this. Okay, this is your subnet ID. So the first host ID, okay, this is going to be your first host ID 25. So the last host ID is going to be 26. Okay, then this is going to be your broadcast IP address. Now if you see the topology diagram, so in this topology diagram, okay, for this subnet, for A, okay, for the subnet A, we have the subnet mask 29/29. So for here, okay, that means for subnet B also we have 29, and for this subnet we have 29 is a subnet mask. But if you see for the subnet D, okay, you are going to have 30, you are going to have. So this concept is called VLSM, variable length subnet mask. So 1, 2. So 2 different types of subnet mask we are using here. So this is called the variable length subnet mask. So I'm going to solve one more problem also. Problem 2 also I'm going to solve. Okay, you can find it in the next video.